Last time, we looked at some problems with the science. One of the things we looked at briefly was the fact that astronomers have got their whole story about the sun and stars wrong. Our favourite critic, Brett, rejected that. He affirmed the story according to the ruling paradigm and challenged me to demonstrate otherwise. Well, it's a really important point. It throws into doubt much of what astronomy has been telling us for 100 years. So let's take a closer look. Since making episode 39, which was about the sun, I came across an outstanding scientist, Dr. Pierre-Marie Robitaille, a chemist and an expert on nuclear magnetic resonance imaging. His expert knowledge of spectroscopy led to stunning advances in image technology. He became very suspicious of astronomical images, as we saw in episode 84. He showed that the famous image of a black hole, which is shown every time a black hole is mentioned, is a fraud. His knowledge of spectroscopy also led him to see that the sun cannot be made of gas, as we are always told. He soon found himself playing the role of David, challenging the Goliath of the scientific establishment and their sacrosanct ruling paradigm in astronomy. But one famous scientist, Alexander Unziker, has joined Robitaille's lone voice crying out in the wilderness.
The standard model solar atmosphere says that there is no real surface, but just one phase, just a gaseous hydrogen, mostly in molecular form. And the standard model, even if there is much evidence for a clear surface, must postulate that this molecular hydrogen, which is clearly not a plasma at 6000 Kelvin, must somehow become opaque, intransparent, in the range of 500 kilometers here at the photosphere, and at the same time it must be totally transparent in the chromosphere, which is slightly above. You see the difficulty here? It's the same substance, the same stuff, the same molecular hydrogen, maybe with a little bit of foreign atoms, but nothing substantially different, but with very different properties. This photosphere is totally opaque, totally intransparent. It just emits light, but just from the surface, not from beyond. And the chromosphere, on the other hand, is totally transparent and just has these foreign atoms we see in the Fraunhofer spectrum. Now, the alternative instead is the liquid metallic hydrogen model developed by Pierre-Marie Robitaille, an eminent physicist who held the world record for nuclear magnetic resonance imaging. And he developed this model of the atmosphere consisting of liquid metallic hydrogen, or a semi-metallic state, which makes much sense because it can easily produce a black body spectrum. Maybe Robitaille would not agree that it's plasma here, but that's a sideline. And then you would have the chromosphere above, which is, as a matter of principle, transparent and contains just some of these atoms responsible for the black lines in the Fraunhofer spectrum.
So the standard model has the photosphere made of molecular hydrogen gas, which is completely opaque. And right above it is the chromosphere, made of the same molecular hydrogen gas, but it's completely transparent. How can that happen? Well, as Frederick Soddy warned us, the mathematicians can do impossible things if you're fool enough to believe them. Astronomers trust mathematics much more than they trust observations. And it doesn't seem to matter that, as Sabine Hossenfelder has told us several times, scientists deal in mathematical fiction. It certainly looks as if they prefer that to observable truth. Robitaille was invited to give a lecture on the liquid sun at the EU 2014 conference all about evidence. An interdisciplinary science conference designed to break the bounds of conventionality. Let's see what he said.
I'd like to dedicate this talk to my mother, Jacqueline, and actually she, maybe like a lot of our mothers, taught me the most important lesson. And we're all trying to learn lessons here, but the lesson she taught me on her knee was to love. When you talk to an astronomer, they tell you, well, the sun doesn't have a real surface. It's an optical illusion. And of course, we can use mathematics to justify that. But the idea actually goes all the way back to Hervé Faye in an article he wrote in Le Monde in 1865, which I translate here for you. So then the exterior surface of the sun, which from far appears so perfectly spherical, is no longer a layered surface in the mathematical sense of the word. The surfaces, rigorously made up of layers, correspond to a state of equilibrium that does not exist in the sun. So surfaces do not exist in the sun. This limit is in any case only apparent. So since 1865, we've thought that the sun does not have a surface. Now, actually, some observational astronomers didn't agree with that. And there were arguments about the sun, did it have a real surface or not? You could find papers into the 1900s. Until then, there were papers by Schuster, Schwarzschild, and of course Eddington, and the sun then became fully gaseous, or been viewed mathematically as fully gaseous, and the observational astronomers just lost that battle.
So we see that mathematical fiction has carried more weight than observational evidence for more than 100 years. Let's look at a few of the observations and see how well they fit into the accepted mathematical fiction.
Now the question for us is, does the sun really have a surface? And there's so much evidence about it, and people have said it a long time ago. There's no question the sun has a surface, and as soon as it has a surface, it cannot be a gas. So we have prominences and coronal mass ejections that can rise from the surface and come crashing back down. They represent real structures, and they are not optical illusions. So this is a little movie here, and you're going to see a coronal mass ejection. It comes back down, and it crashes onto the sun. And when it does, you see all these bright points lighting up. So this is a collision that's taken place. There is a boundary there. It's not just an optical boundary, it's a real boundary. So I'll let you see it again. Now here's another line of evidence that the sun has a real surface. We have Carrington rotation on the sun. We've known this since the 1800s. So the sun exhibits differential rotation on the surface, as first highlighted by Carrington when he was observing sunspots. But the coronal winds are orthogonal to this direction. And because they're orthogonal, this requires a physical boundary. So this is one of the simplest proofs. Because you have this orthogonal displacement of matter, you must have condensed matter there. A gas cannot do this. Now here, this is an example from X-ray. So if you look at the sun in X-ray, what do you see? If you look at the line intensity is about 1 over the entire radius of the sun, over the entire disk, except at the limb. Exactly at the limb, as soon as you cross the surface, the line intensity doubles. And if you think about that, that means you're sampling twice as much atmosphere all of a sudden, and this shows that you have a discrete surface when the disk ends. So we see it in X-ray. Basically, at every frequency band, we see it. Now this is a nice, simple line of evidence, and this figure is important because it shows transverse waves on the sun. So this is a Doppler image. You're seeing a flare coming out in white at you in the upper left. So as the flare comes out, you start seeing transverse waves produced on the surface. And transverse waves can only exist in condensed matter. Gases cannot sustain such waves. And this, by the way, is over millions of meters. And so the wavelength here is millions of meters. This is definitely not a gas.
The next part of his lecture might be a bit obscure to non-scientists. He deals with emissivity. That means how well a surface can emit radiation. If a surface has high emissivity, radiation from it will look bright. If it has low emissivity, it will look dark. Emissivity changes depending on the angle of the surface to your line of sight. A non-conductor like stone emits radiation roughly perpendicular to the surface. So if you look perpendicular to the stone's surface, radiation from it will look brighter than if you look at an angle to the surface. A good conductor, like silver, has low emissivity, and it emits radiation at a steeper angle to the perpendicular. So if you look perpendicular to the surface, radiation from it will look dark. And as the angle of the surface to your line of sight increases, it will start to look brighter, reach a peak, and then look darker again. That's not the case for reflections from the surface, only for radiation from its surface.
So, what is directional spectral emissivity? Well, this is actually important to this society. The emissivity of a material depends on whether or not it's a conductor. So if it's a non-conductor, its normal emissivity will start high, so it's up here, and then as you increase the angle of viewing, the emissivity drops. If it's a conductor, the normal emissivity is low, and then as you increase the angle, the emissivity goes up and then finally drops. You could read about that in the papers described below. Now here's an example from the emissivity of granules. Now granules, of course, are substructures on the sun, and they're what most of the surface is made out of. And granules are best explained by Baynard convection. That's a surface-driven process. So if you don't have a surface, you're not going to get Baynard convection. So you have convective upflow coming through the center of the granule, and then it recedes on the edges. Okay, so it looks like a little mountain. So what does that mean? Well, if we go back to our plot again, what we know is that on the angle, when it goes down, we're increasing the angle. So as it goes down, it's going to be dark. So we're going to have these dark intergranule lanes, and that's exactly what you see. It looks dark. You have these dark intergranule lanes. Now in the gas model, they say, well, that's because the temperatures are different. This temperature is different than that one. These are all different temperatures. Every time you see a different color. I say no, the temperature is pretty much the same, or the energy content is pretty much the same, but the emissivity changes because you've changed the direction that you're looking at it. Here's an example from sunspots. Now for 100 years now, they've been telling us that sunspots are cooler. The umbra of sunspots are cooler. Now, the first thing about sunspots is they're a manifestation of a real structure. They're not optical illusions. So if the surface is an optical illusion, you surely can't have a real structure. They are magnetic in nature. This is well known. And that's indicative that they're highly conductive. Their emissivities are best explained by directional spectral emissivity in conductive materials, not solely by temperature. So you're not really looking at a temperature effect here. The reason that the sunspot appears dark is seen in the lower figure here. See? These materials are at the same temperature, but this one's a conductor. So its emissivity is going to be low, just like silver has a low emissivity, right? So that's why the sunspot appears dark. It's not because it's cooler. It's because it's more conductive. Now, as I've said in my talk on Kirchhoff's law, the Achilles heel of the gaseous sun is this spectrum. There is no way that a gaseous sun can produce a continuous solar spectrum. Now I have this slide, the father of the gaseous sun, one of the fathers of the gaseous sun. Now, it's interesting that I call him a father of the gaseous sun because if you read this quote, you'll see that Kirchhoff actually believed that the sun's photosphere was either solid or liquid. He didn't believe it was a gas at all. But the problem is that Kirchhoff gave Kirchhoff's law. And when he wrote this law, which we just discussed in the previous talk, he permitted the astronomers to make the sun a gas. So, according to Kirchhoff's law, as long as the sun can be considered to be enclosed, then it must contain black radiation, even if it's gaseous. Obtaining a thermal spectrum is not a difficulty, okay? Yet, was Kirchhoff's law actually valid? Do arbitrary cavities really contain black radiation? And if so, why are all the laboratory black bodies always constructed from nearly ideally absorbing materials? So clearly this wasn't right, as we discussed in the previous talk. Arbitrary cavities do not contain black radiation. And of course, as I mentioned in my Kirchhoff talk, these papers have all been submitted, and the last one is not just submitted now, that's already published. So the gaseous model of the sun cannot account for the thermal spectrum. That is the only proof that's required to establish condensed matter. I wrote 40, but you actually only need this one. I really don't care about the others because this one has a lot of physics in it. But we'll throw in the others because sometimes people can't understand this one, but they see the ripples on the sun and they can understand that one. Now, who are the notable advocates of a liquid sun? The first was Kirchhoff himself, and unfortunately, his law undid it. Lord Kelvin was also a prominent advocate of the liquid sun. But the most notable advocate of a liquid sun was James Jeans, and he was a phenomenal scientist. And the story of James Jeans' sun is described in the follow-up paper to the first one. Now, Jeans, he had a different approach. Why did the liquid sun die? He thought all the stars were liquids. And the reason it died is that he thought the sun was made of uranium or radium. Well, when it was proven that the sun was mostly made out of hydrogen, of course, he was out of a building block. You know, I was trained as an inorganic chemist, and you learn in chemistry that hydrogen is the little cousin of carbon. So isn't that convenient? Now, right at the time that Jeans was losing his building block in the 1920s and had to abandon his liquid sun, if he had read Wigner and Huntington's paper, he would have had the solution. Because Wigner, who's a Nobel Prize winner in physics, said that at high temperatures and pressures, hydrogen will become metallic. It'll assume a structure which will be condensed. So let's read exactly what he said. The objection comes up naturally that we have calculated the energy of a body-centered metallic lattice structure only, and that another metallic lattice may be much more stable. We feel that the objection is justified. It is possible, however, that a lattice-like lattice has a much greater heat of formation and is obtainable under high pressure. Diamond is a valence lattice, but graphite is a layered lattice. So here what happens is Wigner and Huntington in 1935 tell us that hydrogen can assume the graphite form. Then Neil Ashcroft, which is one of the top condensed matter physicists in the world and a great authority on metallic hydrogen, wrote a paper on a little reflection. It is apparent that all the quantitative remarks just presented on the band overlap state in dense hydrogen could have been made with minor modifications about graphite, the tetravalent hexagonal band overlap 1 atmosphere semi-metal. Accordingly, it is instructive to examine the known optical characteristics of graphite. In the visible range, graphite appears black. To some extent, these characteristics are reported to be shared by very dense hydrogen. One possible choice for the structure of dense hydrogen consistent with hexagonal symmetry is actually a graphite-like arrangement. And then, lo and behold, some people are working while the rest of us are sleeping. And this group, actually recently created dense hydrogen with a graphene structure. So the spectral signature of the strongly interacting hydrogen molecules is consistent with the presence of graphene-like sheets, a configuration predicted in early calculations on dense hydrogen. So now we have something quite close in the laboratory. So again, this is the structure that we're looking for.
So the objections which were brought against Robitaille's liquid hydrogen sun have been answered. Why are astronomers so reluctant to accept it? Unziger looked into that.
What is evidence? Because it's very easy to dismiss the liquid metallic hydrogen model if you look up, for instance, Wikipedia, and you see the pressure and you see the density of the, say, the chromosphere or the photosphere, and it's in huge disagreement with this model here. And for that reason, it's very important that you distinguish direct, undeniable evidence from model inferences. And the direct evidence we have from the sun is really just the solar spectrum, nothing else. Now, of course, what you can reasonably assume that this spectrum arises from a more or less 6K black body. That's clearly what the wavelength and the spectrum shows, but there are a lot of other hidden assumptions which enter the back door of the model and are not really direct evidence. Now, I have argued in this video that the sun is not made of gas simply because gases emit discrete lines, and this is a continuous spectrum, contradicting the most direct evidence we have. And then you may have heard that the sun is a plasma, and of course a plasma, as a matter of principle, could also produce a continuous spectrum, but the plasma, and we are talking about the surface of the sun, okay, not the inside. The inside could be a plasma, okay, but if you talk about the surface of the sun, it's not a plasma simply because it would burn out to the solar system all planets we know. It's much too hot. You would need 157,000 Kelvin around that. Now, I'd like to compare a little bit these two models. I think that there are some interesting general methodological differences. The liquid metallic hydrogen model, it accepts the obvious observation, the evidence that there is a surface, that there are surface waves, that there are coronal mass ejections. All this points to a real surface, to a different state, and the standard model explains a lot of illusions. They have to explain why there is an illusionary surface and not a real surface, why there is so much opacity and it's not transparent as it should be, and so on and so forth. But the point is, you do all this because in the standard model you have known computational methods, you know what to do, but you're making a lot of counterintuitive, simplistic assumptions.
I think Unziker is right on the mark. The evidence that there's a liquid surface is being explained away as illusion by mathematical fiction. The fact that it requires counterintuitive, simplistic assumptions and free parameters which can be fudged to make things work out in the mathematics seems to be acceptable to the astronomers. And I suspect the real reason why it's acceptable is because the astronomers want to carry on writing research proposals, motivating funding, and producing worthless papers by the hundreds. It really doesn't seem to concern them very much whether their model is wrong or not. The metallic hydrogen model would overturn their comfort zone. They would have to start thinking out of the box and looking for new, innovative solutions, designing challenging new experiments, constructing new physical theories. The things Sabine Hossenfelder told us she wanted to do, but could never get past the constraints of the paradigm-bound watchdogs who control the funding. How sad that truth is no longer part of the science. How sad that the science cannot allow a divine foot in the door. How sad that Christ is an unmentionable persona non grata. He told us, "I am the way, the truth, and the life." And as the Bible tells us, because they received not the truth, that they might be saved, God shall send them strong delusion that they should believe a lie. Thank you for joining me for this episode. If you enjoyed it, please like, subscribe, and press the bell so that you'll be notified as I release new movies. If you'd like to support this project, you're welcome to do so through Patreon. Find a link on my channel banner and in the description below.